Hi everybody. I'm going to do this assignment called Coordinate Geometry, finding slope, distance, and midpoint. You're going to do an assignment just a lot like it. Here's how I'd like you to do it. Do it like this. We have the coordinates points A, B, and C. We're going to show triangle ABC. A is at negative 4, 7, so I should go left 4 and up 7. I don't have to be perfect about this, but I think that finds point A to be somewhere about there. And I ought to put an A by that, so I know where point A is. And B is over 4 and down 1. There we'll find point B. We understand that the first number tells us right or left, and the second number, the y-coordinate, tells us up or down. And the third coordinate for point C is right 6 and up 5. So I'll do just that. There's 5, 6, and up about 5. I think that finds that place right there. And I'm going to show that point C. And then I'll show triangle ABC. The best thing for you to do is do this while I'm doing it, this practice page. And then I'll have a page for you to work out and get a good grade for. So there's my triangle ABC with coordinates left 4 up 7, over 4 down 1, over 6 and up 5. The next thing it asks me to do is show the application of the slope formula and find the slope of line AB. A couple things to think about. As I look at line AB, what do you think its slope should be? Should it be positive or should it be negative? And clearly, from left to right it's going down, so we should call that a slope to be negative. And you must remember the slope formula, which I'll write right here, and you got to memorize it. Y sub 1 minus y sub 2 in the numerator over x sub 1 minus x sub 2 in the denominator. I'll zoom in on that for a second. If I try to zoom in on that and say, man, there's the slope formula, and don't you forget it. We're going to use it to find the slope between points A and B, with A being at negative 4, 7, and B being at 4, negative 1. So y guys got to go on top. So that would be with 7 minus negative 1, y-coordinate minus y-coordinate with that negative 1 y-coordinate. And if I use that y-coordinate first, I must use this x-coordinate first. So I'd follow with negative 4 minus 4. And then I got to do some calculations here. 7 minus a negative 1, that's a positive 8. Negative 4 minus 4, that's a negative 8. I should reduce this fraction. Whenever you have a negative sign in the denominator, the bottom of a fraction, you should always move it to the numerator. And I would say that this is a negative, 1 over 1. That's what I'd say the slope of AB is. It is negative 1 over 1. And when I look back over here at the line, does it look like AB is going down 3 and over 3? It does. Or down 1 and over 1? Yeah, it does have a slope of negative 1 over 1. I don't care if you can tell by looking at the graph. I want you to show me the use of that formula. And the next thing we're going to do is use the distance formula. It's a little more interesting. The distance formula looks like this. Has a square root, couple pairs of parentheses, plus sign between them. And the parentheses have squared, they are squared. Those are exponents of 2. And in the first pair of parentheses, it'll be the difference in the x-coordinates. X sub 1 minus x sub 2. In the second pair of parentheses, it'll be the difference in the y-coordinates. Y sub 1 minus y sub 2. I'm about to use these same 2 points, A and B, which were at negative 4, 7, and positive 4, negative 1. I'm going to find the length of that segment AB. I'll use the distance formula, as I'm told to do so right here. So I'm just going to lay out these pairs of parentheses, and I'm going to fill in the blanks in a moment. That's kind of how I always do it, and it works for me. In the first pair of parentheses, I'm looking for the difference in the x-coordinates. The x-coordinates being these, I should show negative 4 minus 4. In the next pair of parentheses, the difference in the y-coordinates. That would be 7 minus negative 1. Then I just have to do little calculations. Negative 4 minus 4 is really negative 8. But I got to square it. And 7 minus a negative 1 is really a positive 8. I got to square that also. I'll work on that some more. So I hope you recognize that any negative number squared is a positive. So that will just be a positive 64 plus, and 8 squared is clearly 64. So that is the square root of 128. Let me show you a little something about that. The square root of 128, a little aside, please. Let me just show you that I know the square root of 121 is 11. So this length should be a little bit more than 11. Let me just show you something I think is kind of cute. I'm going to measure what I think to be 11 right here. And I understand starting from this place to this place should be 11. That should be a length of 11 there. Now I'm just going to measure how long AB is and see if it's that same length. And it's very, very close to that same amount. You would have to agree. My graph isn't perfect, but really close. So I'm thinking, yeah, that's probably right. That's square root of 128. But there's another thought to consider. Since 128 is 64 times 2, you see there was 2 64s that went in there, I can reduce this radical. If I think of that as 64 times 2, since I know the square root of 64 to be 8, it comes out of the radical, becomes an 8. I do not know the square root of 2 except an approximation, so I leave it inside the radical. And there's my answer for the length of segment AB. It is 8 times the square root of 2, which is equivalent to the square root of 128, which is a little bit more than 11. Now, we're going to use a midpoint formula. And I should give you the midpoint formula. I'll do that immediately. The midpoint formula looks like this one. You add the x coordinates, x sub 1 plus x sub 2, and you divide by 2. I go around thinking it's the average of the x coordinates, comma, the average of the y coordinates. Y sub 1 plus y sub 2, also divided by 2. There, my friends, is the midpoint formula. But we're going to get the midpoint of m of AB. So I'm going to work on that now. I'm going to get midpoint m. That should be the midpoint of AB. Where kids make mistakes is they use the wrong points. Be careful here. So I should use the point, I think I'll do it on another piece of paper. I'm using the point negative 4 comma 7 and 4 comma, oh, I'm not supposed to do AB, I'm sorry. I'm supposed to get the midpoint of AC, aren't I? And it makes a big difference. So let me do that better. AC, which was from negative 4, 7, that's at A, to C, which is at 6 comma 5. And I should add the x coordinates. That's negative 4 plus 6 divided by 2. And then adding the y coordinates, 7 plus 5, also divided by 2. Negative 4 plus 6 is just 2. Divided by 2 will be 1. 7 plus 5 is 12. Divided by 2 will be 6. So I'm going to go back to my regular page and say that midpoint should have been at 1 comma 6. But because I make mistakes, I'm going to go check my graph. I'll look at that graph. Let me scale out a little bit. Excuse me. And I'll go to the point 1 comma 6. If I go to the right 1 and up 6, I think that would take me to this place right there. And I think that's a pretty good looking place for the midpoint of AC. I think if you looked at it, you would have to agree. So M should have been at 1 comma 6. I should have written it there. Now I need to get the midpoints of segment BC. I need to get the midpoint N of segment BC. So I'm going to get those couple of coordinates. They're right here. And I'm going to get their midpoint. Remembering, how do you get a midpoint? You add the x coordinate, 4 plus 6, divided by 2. Add the x coordinates and divide by 2. And then to get the midpoint of segment BC, I'll add the y coordinates and divide by 2 as well. Negative 1 plus 5, divided by 2. That 4 plus 6 is 10, divided by 2 will just be a 5. And negative 1 plus 5, that's just 4, divided by 2 will just be 2. So I'm saying that midpoint should be at 5 comma 2. I'll report that right here at 5 comma 2. I want you to show that work. I just didn't want to crowd up my page. Let's go look at that graph and see if 5 comma 2, it looks like the proper midpoint. If I go to the right 1, 2, 3, 4, 5 and up 1, 2, I think you would have to agree with me. that that place N does look like the midpoint of segment BC. Now the exercise we're going to finish this up with talks about this segment, the thing that joins two midpoints together. It's called a midsegment. This segment MN has special properties. We could read through this together. The midsegment, that segment that joins the two midpoints, the midsegment theorem tells us when the midpoints of two sides of a triangle are joined, that segment is parallel to the third side in 1/2 of its length. We will show that this is true for our triangle ABC. So now it asks me to use the distance formula to find the length of segment MN. Remembering that M had coordinates 1, 6, and N has coordinates 5, 2. Now here's a little heads up. Because we thought earlier that the length of segment AB was 8 times the square root of 2, that this length is 8 times the square root of 2, and since MN is supposed to be half of that length, you might be wondering, well, what would be half of 8 square roots of 2? We're about to figure that out. Maybe you would know it already. But let me use the distance formula between these 2 points. That should figure it for me. So I'm going to say that MN will equal, and then I'll go with the square root of, and inside that first pair of parentheses will be the difference in the x coordinates, and the second pair of parentheses will be the difference in the y coordinates. Here goes the distance between M and N. That would be like 1 minus 5. I think of that as the difference in the x coordinates. And then in the second pair of parentheses, 6 minus 2. And then I just have little calculations to do. 1 minus 5 I recognize to be negative 4. But I'm going to square it. And 6 minus 2 is just a positive 4. And I've got to square that also. So as we think this through, negative 4 squared, I hope you recognize any negative number squared is always positive. That's going to be a positive 16. And this 4 squared is also a positive 16. So this, I come up with a square root of 32. I can reduce that radical because I know a perfect square that goes into 32. 16 is a perfect square and it divides cleanly into 32. I can think of that as 16 times 2 is the same as 32, and because I know the square root of 16 is just 4, I would report this that is 4 times the square root of 2. Let me recap a couple of thoughts right here. Here I think that MN is 4 times the square root of 2. But we knew from the earlier on this page that AB was 8 times the square root of 2. And it is clear to me that 4 square roots of 2 is 1/2 of 8 square roots of 2. So I can make this decision. MN is equal to 1/2 of AB. I wouldn't put segment markers on these because I'm talking about their lengths. But that shows me that, in fact, MN is 1/2 the length of AB, which is part of what we call the midsegment theorem. There's only one other part. We want to show that that segment is also parallel to the third side. To decide if MN is parallel to AB, we should consider their slopes. We already know what the slope of AB was. It was negative 1 over 1. What do you think the slope of MN should be? Let's work on that right now and figure that out. I'll copy the coordinates of point MN up here so I can work with it. M was at 1, 6, and N was at 5, 2. And I'm going to find the, let me show you what I'm working on. Now I'm going to use the slope formula between those 2 points. The slope formula is y coordinate minus y coordinate on the top. So that would be like 6 minus 2. And in the denominator, I'm going to do the difference in the x coordinates. But if I use this y coordinate first, I must use this x coordinate first. So I follow with 1 minus 5 in the denominator. Just like you did slope in Algebra 1. But it's really important. So 6 minus 2 gives me a positive 4. And 1 minus 5 gives me a negative 4. Yeah, we can reduce that fraction. You always bring the negative sign to the numerator, and 4 divided by 4 is equal to negative 1, is equal to 1. So I have a negative 1 over 1. And I say, well, that's the slope of segment MN. And I would denote it this way. MN has slope equal to negative 1 over 1. Since the slope of MN equals the slope of AB, I can say therefore, and that's what those three dots mean, therefore MN is parallel to AB. And that would instantiate the midsegment theorem. I've done everything I need to do on this page. Now, I'm going to give you a page to work on like this. Do not turn this page into me. That would just be a terrible thing to do. I'll give you a 0. But you're going to do the page just like it that says a little more practice with coordinate geometry. When you do that and get it to me, we'll have another grade for you, and happy that we can work together. Thanks, and fun to talk to you.